I've got our first nonlinear inequality up here on the board, y less than or equal to x squared plus 1. You'll notice our boundary curve, as always, is what we get if we replace the inequality with an equal sign. Because where two things are equal is going to be the boundary between when one part is bigger and when the other part is bigger. Okay. But that's not a line, that's going to be a parabola. Okay. Still, that's going to be my boundary. I'm going to draw it. This was an inclusive inequality, so this is going to be a solid curve. As we're working with nonlinear inequalities, we'll get to review some of the graphing that we've done throughout the semester, which is kind of nice because the final exam is approaching, and so you want to be reviewing these things anyway. Looks like this is going to be a transformation of my basic parabola. We're adding one after we square, so that adding one is going to shift things up one. It's a vertical shift. Okay. So if I were to sketch that parabola, instead of having its vertex at the origin, its vertex is going to be at 0, 1. And we're not scaling things at all. So to get another point so that I get about the right steepness, I can just come 1 over and 1 up. And that's the approximate steepness of my parabola. Okay, now I drew that as a solid curve, as I said I should. Now, notice that parabola divides the plane up into two parts. There's this part that's sort of inside of the parabola, and then there's this part that's outside of the parabola. Now, because I've got y less than or equal to, I want to be thinking in terms of above or below. Okay. Well, if I'm here, we're above the parabola. Because if I'm here, I'm above a point that's on the parabola. If I'm over here, I'm more inclined to say I'm to the right of the parabola than I'm below it. But this parabola is going to keep going up and to the right. So there's going to be some point directly above here, way up high, that's on that parabola. This point is below that point on the parabola. So the stuff inside the parabola is above the parabola. The stuff outside is below it. Because we're looking for where our y values are less than or equal to, we're going to be shading below. Now, I'm shading all the way over here. It doesn't look like there's any parabola over here, but I know these arrows indicate that we keep going up and to the right, up and to the left. I know my domain is all real numbers. So it was just that the points that are over here with these bigger x values or these more negative x values are so high up that they didn't fit on the board. But there will be a point on the parabola that's above this stuff, so this is actually below the parabola. If you feel more comfortable with a test point, certainly possible to do, notice I could pick the origin. If I pick the origin, it becomes a true-false. 0 less than or equal to 0 squared plus 1, 0 less than or equal to 1, that would be true. And you'll notice we shaded the side that contains the origin. Okay, so I'm going to give you folks one to try. I want you to see if you can graph this one, y less than the square root of x plus 1. Okay. See if you can graph that. I am going to just give you a word of caution. This does not have as its domain all real numbers, right? I know this is only going to be defined if the quantity under the radical is not negative. So it's not defined everywhere. If there's a part of the plane where there's no graph, if there's no graph, there's no above the graph and there's no below the graph. So we're only going to be working in the part of the plane that's in the domain, where the x values are in the domain of this function. Okay. So give that a shot. See if you can get this graphed, and then we'll go over this at the beginning of the next video.